Ladies and gentlemen, we've got a lot to cover today. This is effectively Season 2 of the How to Make a Metroidvania series, and I'm going to jump into it as quickly as possible. I'm going to show you a short demo now of what I've made. This is going to be our enemy without a brain, and this is going to be our character able to hit said enemy and kill it. So a couple of things to note, I am still working on some things, so we're just going to try and ignore this dude who's chasing me for the moment. He's slower than me, so he'll get out of the picture real quick. As I said, enemies don't have a brain right- oh, I can't jump. Enemies don't have a brain right now, so if you let me just platform up here for a bit, we're going to jump across, and we're going to find this guy. This guy is what we're going to be making. I didn't put him down below because I wanted to get that other enemy working, but then I didn't upload for an entire month. So, we're just going to work on getting everything going today. Right. When I click, we have... oh, I should probably bring the console in over here. Over here is our console. In our console, we have a little message now that I've done the attack animation. You done been hit, big brain enemy. That's a lie, he doesn't have a brain yet. He's standing there, won't even look at us, doesn't even know, like, where we are. And Big Brain Enemy took 1 damage. We're going to be writing a script that calculates how to hit what is effectively a brainless NPC. This NPC will stand here, let us keep hitting it until it dies. And you can see there's a damage animation being played. He flashes white, and then he dies. That's what we're going to be making. Oh dear, we got a bit of an error here. That's probably to do with something I did in the animator. We're not going to worry about that. Alright, this is what we're making. This is going to be a long episode, so we're going to get straight into it. Sorry I haven't uploaded for a month. In our animator, we've made some differences. So, just as an FYI, the player is also going to be able to get hit, but we might do that in another episode because currently our enemy can't attack back. So, right now we have a player idle script. A player idle animation, a run, we've got an attack, we've got this any state thing, which we've used before in the jump layer, the air layer. I slightly reorganized this, but it looks exactly the same. We might go through some changes with that, because I realized I did some things wrong, and we want to fix those. So, we got, yeah, all of this, and we're also going to do some more stuff with animation at points. In our project, we're going to be adding some things that will be interesting. You can see here in a subfolder of the Metrovania, I don't know why I called it Metro instead of Metroid, you can see that we have a characters folder, so we still have our player jump and player move, and our old jump, the hello world script. We're going to create a folder called characters. Characters is going to contain a character, an enemy, and a player. Then we're going to get into something called a state machine. State machine is rather difficult to explain, so I'll explain it when we get to it, because that could be an entire episode in itself. Effectively, they are the brain for the enemy AI. But we're not working on that today, we're just making something that we can hit, and reorganizing our code in a way that keeps everything neat and tidy. Putting the project tab back over on the left, on the right-hand monitor, and we are going to jump into the code. Here is the code for our character script. I'm just going to get the player is open, but we're going to get out of that for the moment. You'll see that in the character script we have required components at the top. Something that will be different is we don't have them in the player because they're already required in its, I guess you could call it, ancestor. Character derives from mono behavior, meaning that we can use things like virtual void update, fixed update, and start, which we've seen before. But there's a lot different. You'll notice that we're using the key term virtual, and further down we'll use things like abstract. These are all terms that you'll become familiar with and you'll know how to use over the course of this. It's going to be a little bit difficult to understand to begin with. I promise I can explain all of this stuff. We're going to be using things called regions. Regions are really simple to understand. They do this. They hide code. That's it. Okay, that's a region. So we're going to jump into our project together, and we're going to start creating all of this today. I am short on time, so we're going to do as much as we can. So the first thing, as I said we were going to do, is we're going to jump into the Metroidvania folder. We're going to create a new folder. We're going to call this characters. So we're going to create a few things. We're going to create a C# script, and we're going to call this character. This is the ultimate parent of every character we're going to make in the entire game, okay? We'll work on what that means later, but if you watch my object-oriented video, you'll kind of understand what derivation means in terms of coding, and you'll know what object-oriented means, and this is the object-oriented parent. We're creating a character abstract object. Now, we need some things to go under that. We're going to create a player. And we've done this before. Everything that we are putting in player probably today shouldn't be too new to you. But there'll be a few things that you'll go, what? I'll explain them. Don't worry. Then we're going to create our enemy, which is why you are all here. The enemy is going to be a lot of fun. It is going to stand there, and it is going to take damage. That is pretty much it. And it's not even going to be the enemy taking damage, it's going to be the character portion of the enemy taking damage. But once again, we'll get into that later. So right now I'm going to open these 3 scripts in Visual Studio. I'm letting it build the solution. If it doesn't build the solution, you'll see that it has build up here. I talked with someone recently, one of my viewers, and pretty much what you need to do, if you don't have the autocomplete that I do, what you want to do is you want to go to File, Edit. You want to go to, I believe it's either Project Settings or Preferences. Give me a second. So we want to go to Preferences, and we want to go to External Tools. Now, External Script Editor needs to be set to the Visual Studio version you're using. If it's 2017, you want to use that. If it's 2019, you want to use that. You need to browse to the file location, and then click on that button. What it effectively does is it tells Visual Studio down here, that's the wrong one, it tells Visual Studio how to run your code, because a lot of the stuff that we use is Unity made, it's not generic C#. Void update has no definition inside of C#. Okay, now that we've got that covered, so everyone should have their editor set up, this is really necessary because you're going to be using references to other scripts. And if you don't have those references there, you might forget what we're doing, and it becomes harder to keep track of things. So that's why I recommend that. So the first thing we're going to do is actually get rid of all of this, because we're going to rewrite them, but we're going to put in words before and after, and it's going to be confusing. So we're just going to try and get through it. Let me get rid of all of this. Okay, so we've got a character, right? We don't ever want to actually implement a base character, so we know we want to call this an abstract character. And this is a public class, because we want other things to be able to use it freely. We want to be able to grab the components from it and derive from it without having to make weird references. Can I put my phone on Do Not Disturb? Let me get my other window open. We're going to drag this over here, and then we're going to go through pretty much line by line. So the first thing we're going to want to do is we're going to go and grab our require components, and I'm going to chuck these just under this bit at the top here. Important to note that when these bits at the top here are grayed out, it means we're not using them. Doesn't mean you shouldn't keep them there, but technically we're not using any of these libraries, namespaces? I'm not sure what they are. C#'s a weird language. Okay, so yeah, the first thing that we would do is require these components. We need them to be on anything, whether it is a player or an enemy. That is like vital and extremely important, because if we don't have these, animations don't get played and characters don't get moved. Okay? So that is why we need those. Moving down, we're going to create some headers like we did in the first actual scripting episode, not the introduction. We're going to create some headers. I'm just going to do, this, and then we're going to copy and paste this. Okay, so the first one that we want to create, Control-C, Control-V. First one we want to create is movement variables. Now, all of these are going to look very familiar because we pretty much just grab them from our player movement script that we've already written. So this makes things very easy. The next one is going to be our jump variables, which once again, we grab from a player jump script, which we've already written. The last one, no, not the last one, there's another one. Ooh, there's 4. So this one is going to be called attack variables. And this one is going to be a little bit interesting because we haven't written it yet. And the one that goes after this is character stats. So the interesting thing about character stats is this is going to be how we track whether our character is alive or dead, which is pretty important for many different reasons. So this is going to track things like health, armor, anything we want to put in the game. Stats-wise is going to go here. This is going to be universal for all our characters. Any variables that we set up that go under here will be on all of our characters, whether we want them there or not. So we've got to remember only to write in the things we need for enemies and players, right? But only the things we need for both, not for one or the other. We need both. Which, by the way, has led me to almost take out the jump variables, but we'll talk about that later because making an enemy know when to jump is quite difficult. Movement variables. We have 3. So we want to create some serialized fields. And we're going to make all of these protected. Basically, what protected means is it shows up in the children, but it can't be accessed from another class. As funny as it might sound, protected is actually the family sharing of the variable protections. Only the parent and the child can access the variables that are set to protected. Nothing outside can get in. And we're going to set this to 2.0f. Now, a reminder that f literally just means this is a perfect 2. This is not roughly 2, it is perfect. We want to serialize our direction, and we're going to make this protected as well. Float direction. We're not going to set this. I like to have a base speed of 2 and everything, but this is something we'll obviously edit, which is why it's serialized. And then the last one, we're going to create a protected bool facing right. I'm going to set this equal to true. We always want to be facing right. We're going to have this little thing down here. So what I'm going to do is I'm going to get rid of that by commenting these out because I'm not ready to talk about them yet. That means that we can run the code that we put in. I created a region for all my mono behavior stuff. I use regions to keep my code organized. Some people say don't use regions ever. And those people are wrong. Basically, some people think it's bad coding practice. I choose to ignore that. It's really handy being able to just do this for like 50 different functions. We're going to create a start function, and we're going to use the keyword virtual. Virtual basically means that we need to define it, but we can redefine it. So there are 2 words that we're going to be using that I've talked about already, abstract and virtual. Abstract means there's no definition for it in the parent. Virtual means that there is a definition for it in the parent, but it will be overwritten. You'll override both, but one of them has a definition and one doesn't. So abstract, no definition. Virtual has a definition, but can be overridden. Abstract must be overwritten. To show you what this means, we're going to open up our player and then our enemy, okay? All right, so we're going to have our player over here. We're just going to chuck him there. And we're going to chuck our enemy in the same tab. So our player, firstly, needs to derive from character. Right, that pretty well makes sense. We want to inherit everything from here, so we are going to make it derive from character. Character derives from mono behavior, so mono behavior gives us the start functions. Character derives from mono behavior, so we have start functions inside our player. We're going to get rid of these, but we still have access to them. Okay, that's why we're doing that. Things that we are going to talk about in our start function. So we have a public virtual void start. What does that mean? Well, it's what we want to do on start. So what did we do inside our player jump on start? We grabbed our components and we set the jump time counter equal to jump time. What did we do in player movement? We grabbed our rigid body 2D and our animator. So it's exactly the same thing again. So what are we going to do here? We're going to grab our rigid body and our animator is equal. We haven't actually grabbed those. We haven't put them in. Hold on. Let me chuck them under here. My bad. We're going to grab our RB. We're going to call this my animator. And then we are going to set these. So we have required them as components. If they are not set, the game will not run. So we need to grab them on our start. So that's going to be one of the first things we do. Equal to get component. and we want to grab a rigid body 2D. And that's that. And then we're going to do exactly the same thing for our animator. We've done this before. My typing is very bad today. Okay, cool. So we can move now, and we can animate our movement based on these two lines, and we can give our movement some variables here, and we can also check whether we're facing left or right. We've got a function that is called turnaround, and all we're going to do is we are going to write that exact same function again. Now, I've got this set up in something called submechanics. It's a region called submechanics. And the reason for this is because it's not a mechanic you think about, but it is one that is definitely, like, necessary. When I want to look purely at the actions the player is taking, I put it in a region called mechanics, which is going to go above here. But the sub-mechanics are the little bits that take place after the character presses a button. So when they press left and then right, I want them to be facing the direction that they are given, but I don't want that to be something that is constantly being thought about. So it's a sub-mechanic, not a mechanic, but it's still a thing that they can do. Anyway, this is going to be a protected void, and we're going to call this turn around. I'm going to write that, get this set up, and then all we're going to do is we're going to go into our player movement. We're going to come down here, and we're going to rewrite this slightly. So this is obviously our flip function. Private void turnaround is the same thing. So we're going to copy this, but we're going to rewrite some of the lines just because this doesn't read as well as I would like it to. So what we're actually going to put in, we can copy the if statement. Let me grab that real quick. We're going to copy the if statement. So if horizontal is greater than 0 and we're not facing right, so if our x value is going up and we are not facing right, well, when your x value is going up on a Cartesian plane, you are traveling to the right. If your x value is going down, you are traveling to the left. So if we're doing this, we want to be turning around, right? Now, the line that we want to do, and we have our facing right thing here, is we want to invert our facing right is equal to not facing right. So we're going to invert this, and then we're going to write a slightly different line to what we did in the last one. In this one, we effectively take 3 lines to write something that we probably don't need to, and while this reads well, you know, you make a copy of the scale, you times it by -1 on the x, and then you reset the scale so that it's times -1. It works, it's readable. I'm going to use a different line because I prefer it. You guys are free to use this if you want to, but I'm going to use my line. So we're going to write a new one here, .local scale is equal to, and we're going to create a new vector 2, and we're just going to throw it transform dot local scale dot x. We're going to multiply this by -1. So this is where we are inverting the transform, and then we're going to pass it y with no changes, and then we are going to put a semicolon at the end of that line. Don't forget your semicolons. We can turn around, and we have a start function. Currently, there's nothing here that we need to overwrite because we don't have stats. We can turn around now, right? So it would be good to set up maybe some movement functions. All right, yeah, so we're going to create our region mechanics. And all we're going to do here is we're going to write a very simple script. In fact, I'm not even going to write it. I'm just going to copy and paste it, and you guys can read through it. Okay, so this is going to be it. We're going to create a protected void called move. Now, the reason that this is protected and not virtual is because we don't actually ever need to redefine this. This is always going to be exactly the same thing. We have a speed on our character that we will change if anything is going to happen. But pretty much, we've got our rigid body dot velocity. So that is the velocity of our character. And then we are going to create a vector 2. And we are going to give it direction multiplied by speed. So we're going to give it direction and magnitude in a single direction. We're going to pass it back whatever our y is because we don't want to move on the y, just the x. I am explaining this because, once again, I've spoken to some people who didn't know what a vector 2 was, which is, I mean, if you haven't done maths to, say, a year 11, 12 level, you probably won't have touched it if you haven't done physics either. So, yeah, a vector is just a speed with a direction. That is all it is. It's, if you remember that guy from Despicable Me, it's direction and magnitude. So a vector 2 is literally two vectors next to one another. It's your x and y vectors. Now that we've got our move function, we can actually try using it, which is where we're going to create our first handle section. This is going to go in the sub-mechanics, so we can open this back up, and we're going to put this above turnaround. So I'm just going to shut turnaround, because we know that that is... Well, we're pretty sure that's going to work, considering it's exactly what we did last time. Protected virtual void. And all we're going to do in here is we're going to call move. Now, we might redefine this in the player character, but it's unlikely. It's not necessarily something we need to do. By the way, this is also not something that you absolutely have to do. If you don't want to create the character and do it this way, you don't have to, but I had this thing, this little demo, and I was going to talk about it briefly when I got to this point. We're going to scroll back up to here. Basically, this is coding principles every programmer should learn. So, the first one, and it's a big one, is don't repeat yourself. Don't rewrite your code. It is annoying to do. You don't want to do it. Your job as a programmer is to work as quickly as possible putting things in. DRY. Do not repeat yourself. We have a move function here and a handle movement that calls move. Why do we have that? We can modify what is happening when we're moving now, which is very important. But when we move, we always want this to be exactly the same for any character, no matter what they are, player or enemy. This can be expanded upon. This is always going to stay the same. We don't want to change this. We want to change this. Okay, that should be enough of that. If we're purely handling the movement right now, which I think we just need to do to get through this episode because it's taking forever. The next thing we probably want to do, we want to create a fixed update region. So we're going to go back into our monos. We can shut mechanics and sub mechanics, and we can go into our monos. We're going to create this under here. I'm going to create an update and a fixed update at the same time. Now you'll notice later on that when we get into the jump, I'm not going to be putting it in update. I'm going to be creating another, I'm going to be creating more handle functions. Handle functions are everything that happens when it gets called. But like the very focus on how we move should be noted, but handling everything at the same time is always good. Which is why we're going to create handle functions, and it's also going to clean up our update section. If you remember, we had a bunch of if statements. Now, when you've got a script dedicated to movement or jumping, it's fine to have an update function that is like this long, but it's better to have one function that does a lot that's not your update, because you want to call everything an update, right? So it's more readable to have your update function clean and then have functions dedicated to what you need to do. So you can just look at that one function without having to scroll in between the different bits of update. So if I just simplify update by going handle movement and handle jumping, it's much more readable to just go to handle movement and handle jumping than it is to put both of them in update. So that's why we're doing it this way. Moving on, so we've got our virtual void update. This is where we are going to handle input. We worked out that handling input in here was better. So this is where we are going to handle mechanics / there we go. I can spell. Right, so we've got a fixed update. What do we want to do in here? We want to handle movement. That's pretty much it right now. There's more stuff that we'll do later, like handling layers, but we just want to focus on handle movement right now. As I said, so far, not really anything we haven't done, except adding one extra function, which is going to call another function down in the mechanics section. I'm trying to work out if we are good and whether we can start working on our player yet. One thing, looking at the other script that I'm noticing instantly, is we don't need, and I've written this out, so this is bad practice, so I'll show you this. In here, we have a reference to our fixed update, but we don't change anything. So this can actually be deleted. I might put it back later, but right now we don't need it, so it's gone. Okay, but we're going to write this override, public override void update section inside our player now. And this is where overriding becomes a thing. So we've got an update function, which we said wasn't going to do a lot. Well, we want to change that for our player. So inside here, we were going to do stuff like handle jumping, I believe. So technically we could put that in, just jump revamping and do that. So this is already what we're going to be doing. But inside here, we want to change some of this stuff. The player itself, the player as a person, has a brain. The enemy doesn't. So how does the enemy get its direction? Well, we're going to write some scripts that tell it where the player is, and those are going to give the enemy direction to move and all that kind of thing. Our player is just going to give some input. So we're handling the input for movement here. Basically, all we need to do right now is we need to tell our player character that he needs to refer to what is going on inside update and inside fixed update. He doesn't need to refer to that because it's already derived, but he needs to refer to update. But we also need to override update so that it's not just doing this stuff. It needs to do more. So what we're going to do, and this is why autocomplete is going to be fun, because it'll do it for us. So we're going to put in an override void, and it's going to check inside here the different functions that we have that are set to virtual, right? So we've got 3 virtuals right here. And you'll notice when I start typing here, it's got fixed update, start, and update. Well, those are our 3 virtuals. So which one do we want? We want our update. And you'll notice that when I click on it, it says base.update. So that is the character that it is deriving from. So, well, the player is deriving from character. So it's taking the base. This is the stem of our tree. And this is one of the branching off roots. So it's taking our base. And it is putting, this function. And it is putting all of this in here. We don't actually have anything in here yet, but that's because I haven't done jumping. Jumping will be really quick. It's a quick copy-paste job, which we won't do just yet. But effectively, all we're going to do in here is we're going to have our base.update, and we are going to write direction, and we're going to give our character direction like we did in our player movement script here. So we're going to scroll up to update, and you'll see that we've got horizontal movement. I decided that that was a little bit iffy of a name. It didn't explain very well, so I changed it to direction. Input.getAxisRaw. Oh, whoops. And as we know, this takes a string for the axis name. We have one called horizontal for our horizontal movement, which is capitalized. I just had to check. And that is what we are going to put in here. Now, if you were to put this in the enemy script, your enemy would be moving based on the direction of your keys. So you would be controlling both your enemy and your player. We don't want that, which is why it's only in the player character. We want to call things like handle jumping and handle, say, attacks and that kind of stuff in like the player, because it's going to be told what to do when handling all of that kind of thing. To handle jumping, you need input from a certain source. For the player, we get the input from the player theirself. The enemy is going to need a whole lot of scripting to be told how to handle jumping. But when it handles jumping, which is going to be called constantly an update, it's going to know what to do based on the script, not based on what the player does. We're going to rely on the fact that the enemy is going to be given a state machine, which is going to tell it what to do. And we're going to put all our handling inside the character, just based on the handling is going to work based on input it's given. Right, the last thing we need to do, we're going to set a different speed. So in start here, at the top, we set a speed in here. And that's fine, you can do that. But I want to override the speed because I want my character to be a little bit different. So actually, I'm going to change this from 2 to 1 because I like some enemies being slow. And I prefer they start slow and I make them faster than start fast and make them slower. That's just my developmental process. I don't know about you guys. So we're going to worry about this now. So we are going to create a public override for the character's start function. So we're going to create a void start. And all we're going to do in here is we're going to, actually above here, we're going to create a movement speed. We're going to make this private. We're going to use our movement speed inside our player instead of our actual derived character movement speed. Actually, we can rename this. So instead of movement speed, I'm going to call this run speed. And we're going to have an exact copy of this called movement speed. No, we got speed in the character's thing. Okay, and then we're going to have a private float walk speed. So this is going to be so that we can actually press a button and slow down if we want to. Because I like having that kind of functionality in a game. And we're going to set movements, we're going to set our speed, right? So our character's base speed is going to be equal to run speed in the start function. Because we're also going to set later on a bool that says that we don't spawn in with our sword out. Little bit of a level design tip. If your character is about to spawn into an area, they should never spawn in on top of enemies. They should always have to progress to the enemy, or the enemy will come to them eventually, like at the start of Super Mario. They shouldn't ever have to dodge on the way down from, say, falling in from, like, tunnels and things. That's my opinion. It's not, like, gospel, but I like to make the enemy, I like to make the player pull their sword out, although we could do something where they remember their state from the last level they were in. Anyway, moving on, I'm just going to look through again. Right, so the last thing we need to do is override our movement, because currently, if we remember from mechanics, no, not mechanics, good lord, sub-mechanics, we have our handle movement function, which is just calling move. And that's fine for now. For a character, that is fine, but not for a player. A player needs to be told when and how to... Or, it doesn't need to be told how to move, it needs to be given the option to move. Because we interact with our computer via buttons. So, we are going to create another override of handle movement. There we go. So we got our base handle movement, which is just calling the move function, but then we are going to do something a little bit different. We're going to set our animator to set float, and we're going to grab the speed one. We've done this before, and then we're going to give it math f, so the maths functions group, and we're going to give it the absolute value of our direction. And this is going to tell it which way we are moving. And that's pretty simple. Let's see, is there anything else we need to add to that line? No. And then all we're going to do is we're going to call turn around. Now, I could put turn around in the base, but I don't necessarily know that I want to right now. We're also going to give turn around the same direction that we gave our maths absolute function. That should, given I haven't messed something up somewhere, that should be enough to get our character moving with the base script. So I'm going to jump back into Unity here. And I've already messed up because I didn't put this on, I didn't put the script on the player. I'm just going to collapse all of these. Oh, that's something, really quickly. The box collider, circle collider is causing a lot of bugs. I don't know why, but it falls through platforms. So I'm going to remove both of these. And instead of these, we're going to have a capsule collider 2D. I'm probably going to have to release this little bit as a separate 10-second episode. Alright, we're just going to scale this down real quick. Speed run this. Get that up to his feet. We'll get this wider than his shoulder. Get this down just below his head. We're going to offset it a little bit on the X. We're going to hold Alt. That's a bit better. It's now inside his body. And click. Okay, so now we're going to remove, or we're going to turn these off. We're going to add a component. We're going to add our player. And he is now a player. You can see we've got the speed and direction. You'll remember that we don't have speed and direction up here. We have speed and direction up here. So we know that the character is deriving, the player is deriving from character. So we've got our base working. Now let's see if he's actually moving. And he moves. He can't jump yet. You'll also notice that I've got this thing, Pixel Perfect Camera. We'll talk about that a little bit later as well. That's just a fix for a thing. It's a fix to stop the pixel art from breaking, because sometimes it does that. Pixel Perfect rendering is not a thing that Unity does well. It doesn't work well with pixel art at all. So we're going to use that. Anyway, that's all for this episode. We have a character, we have a player deriving from a character. The character is giving us stats. The player is working on what the character gives us and expanding on it to make the character movable. So this is basically a rewrite of how to get your character moving. Sorry that we have to go back to basics a little bit, but it's necessary for the object-oriented to make sense. I hope I explained everything really well. If I didn't, please get into contact with me. I have a Discord that I'll put down in the description. I also am active in the comments for the most part. I also have a Patreon, which I need to start promoting. So a big thank you to Mr. Zethko, who has been sponsoring me for this month. Tier 2 patrons will get their name read aloud from this point forward. This is a totally optional thing. It is literally, please support me while I make these videos, but only if you can and only if you feel I actually have earned it. Thank you guys for watching. Thank you again to Mr. Zethko for supporting me and this video. I will see you guys in the next one. Bye-bye.